Okay, so what we're gonna do is look a little bit on 1.7 and then continue on with chapter 2. And so I'm gonna go ahead and go over just the paper. We did have one question about this. This is 1.6, and this is sort of like review. It's like one of these problems is no good. It's a bad problem. It doesn't have an answer. And the other two have perfectly good answers. So can somebody spot the bad problem? Yeah, go ahead, Jada. You have your hand up.
You know what it is.
Go ahead.
It's 6 over 0 is the bad one.
This is the bad one. And so the way I suggested you memorize it is that there's an n for number over 0 is a no. This is undefined. It doesn't have an answer. So this is the bad one. What about this one? 6 divided by 1. Anybody know?
6.
This is 6. Okay. And then this is the reverse of this, but this one has an answer because the denominator has a number. So 0 divided into 6 pieces is what?
Is it 1?
No,
It's 0.
No.
0. If you had 0 and you were going to divide it up, you would have 0. You don't. So 0 divided by a number is 0. It has to be a number here. It can't be this example. And this would be true of 5 divided by 0, 2 divided by 0, anything. This is the one that we don't have an answer for. And so that's what I wanted to do. The other thing I wanted to do had to do with exponents. Okay, we did a little bit of this before, but I want to do a little bit more because there's one odd problem here as well. This number here is called the base. So it's the number that's going to get repeated. This is the exponent. And what that means is we will take 5 and multiply it by itself this many times. So two times. And so don't be confused to think, well, 5, 2, it's 10. No, it's 5 times 5, which is then 25. Okay, how's that? Why did I bring that up? Well, because there's a few little odd problems that come in with exponents. And so the next one I'm going to do 5 to the first power. So tell me what that is. What is it?
I have a question.
Okay.
Where is the homework? Because I don't see it.
I'm going to have to do that separately because I'm on the wrong website. I'll get over there in a minute. Who is speaking?
What part are you on?
I'm just making up problems. I'm going over the material we had previously, and so I'm not doing any particular problem. Okay? So you don't need to be thinking about how it's not, I mean, it's in the book, but it's not a specific problem. So here's what I want to do, 5 to the first power. That means you take the base number 5 and you write it once. So that's 5, isn't it? You buy it?
Got it. Would that mean the same way if it's like 5 cubed? Like it'll be 5 times 5 times 5?
You mean 5 to the third power?
Yes.
So that would be 5 times 5 times 5.
Okay.
So 5, and so you can't, most of these, you have to just do them out the long way. There's no quick way to get here. 5 times 5 is 25. 25 times 5 happens to be 125, okay? Now, the reason I started this, because this is zeros. When you see zeros in problems, you need to, like pay attention. This was mentioned in the reading. Now, we're going to write down 5 0 times. It turns out any number to the 0 power is 1. Now, this may not sit well, and it gets easier when we do more work. But for the moment, they're going to occasionally throw this kind of problem in. And the answer is odd, it's 1. Now, I'm going to do a quick little explanation, and you can either like it or not like it. It's okay. So if I had 5 to the 3rd, and as a fraction, 5 to the 2nd, like that. So this is called 5 cubed. This is called 5 squared, if you want to go like that. So that would mean I would have 5 of these. I'm sorry, 3 of these, 3 5s, right? And here, 5 to the 2nd power, I would have 2. Okay, everybody's. So what we did last class is we said, well, 5 divided by 5 is 1. And then we go again, 5 divided by 5 is 1. So when this is a fraction, this is division. When we do this, we end up with 1 left over. But in general, if there's a simpler way to write it, we write it the simpler way. And so that's sort of a general rule. So 5 to the 1st power, we would just say plain old 5. Is that okay? Now, the reason I did this is what happens if I have this 5 to the 3rd divided by 5 to the 3rd. And like I said, either you'll like this or you won't, but I guess it's the best we can do at this particular point. So I would start a 5 with a 5, a 5 with another 5, and finally the last one. How many 5s do I have left?
1.
As far as 5s go, I have 0.
1.
But this is really 1, isn't it? This is 125. If you look at it that way, divided by 125, that's really 1. And so when we did the same thing, we had 0 left over. Like here, I had that 1 left over. And so I wrote it down. But this time I didn't have anything left over. And so if this shows up, you just say, I want the simpler version, because nobody's interested in 5 to the 0 power. They're saying, what on earth is that? And so what they'd rather see is a simpler version, 1. Is this okay with you? So for now, I think we're just going to have to remember it. But I wanted to say there are exponents like 0. There are exponents that will be negative numbers. There will be exponents that will be fractions. This is going further along in your math. And so we're not, we were happy when it was like a positive number like 3, the exponent 3, the exponent 2, that kind of thing. This is where it started to get a little bit strange, but there's more to it. There's more coming up eventually. So we're just not afraid of it. But 5 to the 0 or 4 to the 0 or anything is 1. Okay? And so if you don't like it, that's okay. I gave it my best shot.
I got
Right?
a quick question. Can the exponent itself be a fraction?
Yes,
Okay.
yes, it can. Further down the road, it definitely can, okay?
I was hoping it was,
Yeah,
okay.
yeah, no, I wanted you to think about this because things, okay. So, that was 1.7. And if you had any other questions, let me know. We we did one before class started. I think that's as good as any. It looked like this. And everybody has sort of a similar problem to do, but the numbers may be slightly different. Okay, so this was an example of order of operation. And so your whole idea was to get it down to a single number. Well, it certainly isn't there yet. So I have this parentheses and that one, and then this and that. And so I have got to work inside the parentheses first, which means I have to work this first. So 5 take away 3, I'm going to put it down as 2. I'm going to copy the rest so that I don't get this all messed up. So I want you to see that the only thing I did was take 5 minus 3 is 2, and I copied the rest exactly. Now, remember, parentheses needs to be done first. Now, there's parentheses here, but there's nothing inside to do. It's just like, oh, there's a 2. Isn't that a lovely 2? But it is used here to mean multiply. And so from this part to this part is another parentheses. So it's 8 subtract 3 times 2. Now subtraction is dead last most of the time. And so in this particular case, we would have to multiply before we could subtract. So I'm going to put that parentheses in, and it's going to be 8. And then this has to be done next. Even though you see subtract first, multiplication wins over subtraction. So this becomes 3 times 2 is 6. As you go down the road, it gets easier. At this point in time, we're ready to put these two together and call it a single number. So 8 subtract 6 is 2. And then the 8 was in front of it, and then it was a plus 3. Notice this plus 3 is going to be last, absolutely last. So what we do next is the multiplication wins over adding. And so this is 16. This is 3. And then the 2 together make 19. And that's the answer you turn in. How is that? So that was like double parentheses, and I wanted to do at least one. Okay.
Can you do one more of those, please?
Do you want me to just find it somewhere?
Yes, please.
Okay. Oh, here's one with brackets.
That's what I need help with, is the one with the brackets.
Okay, 2 plus bracket. Whoops, I take that back. 2 plus 5 bracket. 9 plus 3 parentheses. 4 minus 1 parentheses brackets. This one actually is better than the last problem because now you can clearly see that this one goes with that, and this bracket goes with that. And so these are just all versions of parentheses, but we've got to do something inside here to make this right. And so you start with the very innermost parentheses. And so 4 take away 1 is 3. I'm going to keep that in parentheses so I can visualize it. And although you may get to the point where you can do multiple steps, I'm doing it one step at a time so everybody can follow. Inside the brackets, which are treated just like parentheses because they really are just a new another visual look. The 9 plus 3 has to wait. I've got to do this first. Because it's multiply. Multiply wins over add. And so I'm ignoring everything else. So 3 times 3 is 9 for that. And this was 9. And then the 5 was right there, and then it was a plus 2. So these, now that it's down to a single one, we could have made rounded off parentheses, but it really doesn't matter. I have to do this first because this is basically parentheses. And so 9 plus 9 is 18. I'm going to round them off just because I'm tired of the other ones. Okay. So now it's 2 plus 5 times 18. I've got to do the multiplication before I ever do the adding. So I'm going to do 18 times 5, 0, carry a 4. I'm getting 90. If ever I make a mistake, and I think I already occasionally do, just tell me right away, don't wait an hour. Okay, so it looks like it's 90, and then plus the 2 that we had from the very beginning, that one would turn out to be 92. Okay, so you start on the innermost and you sort that out, and you're not done until you get it down to a single number. So the 9 plus 9 is 18. That was a single number. Then we can proceed from there. Okay, if you need more practice with these, you can definitely do a similar problem, you know, with your homework. Okay,
Thank you.
thank you. Okay, so 2.1, we were starting to do some of those, and 2.1 and 2.2 is due on Friday. And so here's some problems. The instructions say, divide the numerator and the denominator. This is the numerator, this is the denominator. Divide each of the following. So this is 12 divided by 9. Now, some people can do it in their heads. Some people want to do it like this. But you want to be sure that the correct number goes on the outside. And so how do you tell which is the correct number to go on the outside? And so I think I've shown this to a few people, but I want to make sure everybody doesn't get these two switched by mistake. If you know you're going to divide it, you can turn this fraction into a division. This number drops down, so that then you have 9 divided into 12, and you have them in the correct sequence, the correct order. Okay? So 9 into 12 goes 1, so you remember that. 1 times 9 is 9. And there's 3 left over, there's nothing to bring down. So when you do this division, it's 1, the remainder was 3 over the divisor 9. Now, if you turn that answer in, they're going to say, couldn't you do a little bit better? You know what I mean? Why? Because 3 over 9 reduces, and they love the simplest answer that you can hand them. Unless they say otherwise, they want the simplest. And 3 divided by 9 is not the simplest. So remember what we did last class. We said, well, this is 3, but this 9 is 3 times 3. And whether you need to do this, some people could just go straight to the answer, but if you're having trouble with reducing, this breaks it down for you. And so I'm going to take out a pair of 3s, 3 on top, 3 on the bottom. The answer then becomes a 1 over 3. So the answer they're looking for is 1 1/3. Everybody okay with that?
How'd you get that 1 over 3, if it all cancels out?
Because when you canceled it, you replace them with 1s. So when you had 3/3, just in general, it becomes 1/1. And that's why this becomes a 1, and this is 1 times 3, which is 3.
Okay, I got you.
Got it. Okay,
Thank
excellent. So let's see. Question?
Yeah, if they not ask no simplify, just we leave 1, 3/9 or
Honestly, let me look. I got answers. My book is really good. Let me look. Number 27. Nope. Oh, I take that back. On that particular problem, I'm glad you asked that. They actually wanted you to divide. And so, although I would, thought they were going the other way, what they were looking for is, does any number divide both of them? And of course, we did it a different way, but the answer was 3. Both of them could be divided by 3. That's actually what they wanted. My mistake. So 12 divided by 3 is 4.
Oh,
9 divided by 3 is 3. This is the way they presented the answer. 4 divided by 3. And of course, that's also 1 1/3. So sooner or later, you've got to take out the 3s. Okay, this is what they wanted. Isn't that interesting? Did anybody learn this? This is an improper fraction?
yes.
Well, the trouble with the word improper is the fact that once you start algebra, if you had 2 choices between this one and this one, most of the time they prefer this. So it seems a terrible thing to call it improper when it's preferred in algebra. Now, we're not there yet, but we need to be able to do, yeah, that's actually what they wanted. Let's see. Here's another one. Let's see if you can reduce this. Do you recognize 55 and 66? It's your best friend, right? How do you get 55, 66, 77? This is 5 times 11, isn't it?
Mm-hmm.
This one is 6 times 11.
Mm-hmm.
And look at what happened. We had a pair of 11s, and so the 11s can be dropped out, can't they?
Yep.
So you're looking for a match, same, that where you're multiplying. And so this one would turn out to be 5 divided by 6. Okay. Anybody have trouble? Oh, I know. There were definitely some problems where you had to figure out where to put it on the number line. Okay, so this was in 2.1. And so what if you had to find the number 1/4? Okay, so 1/4 is between these two. And so let's say it was broken up into 1, 2, 3, 4 pieces. Where would 1/4 be on that number line?
Right after the 0, the dash after the 0.
Absolutely correct. So this would be 1/4. Now, let's say that they tried to trick you. And instead of having four, 1, 2, 3, 4, 5, 6, 7, 8, they had 8. So here was 0. Here was the 1, and there was 8 marks, but you still had to give them 1/4.
You go 8 divided by 4 or something like that. Is the second one, the second dash?
Would be, you're instinctively right, because when it's marked, and I'm gonna count them again, 1, 2, 3, 4, 5, 6, 7, 8. When it's in 8s, you need 2 of them, you need 2 marks to get 1/4, because 1/4 and 2 out of 8 are the same exact thing. So it was easy on the first one when it was divided up just the way you liked it. But when they switched the problem and they put in 8 marks, then you had a different story. Is that it? Let me see. Let me do this one. 15/8. Well, here's 0, and here's 1, and here's 2. Can you tell? Maybe we want to make this a mixed number, which means we divide 8 into 15. Can you do that?
No, you could, but yeah, you could. You get
8
like
into 15, let's see, would go once. 1 times 8 is 8. And when you subtract, there's 7 left over. So this is 1 7/8. That might help us. 15/8 kind of looks strange. This one is trying to put it on the number line. So let's say it was again marked in 8s. Can you tell me where that is? It's not over here. I didn't bother with the marks over here. It's after 1, it's not up to 2, it's between these 2. Where?
isn't it the third from the last one?
Well, we want to go over 7 out of the 8. So this is in 8s. So that would be 1, 2, 3, 4, 5, 6.
Oh,
That's where it would be. Okay? A lot of people ask me questions about this, but when it was marked in 8s, we wanted 1 7/8. So clearly it had to be more than 1, less than 2. And if it was marked in 8, so I had to count over. So it was really just the 1 short of the 2. How is that? See, I don't know if anybody did one of those problems. I'm not sure. We can do,
Yes.
yeah. 3 1/4. This is section 2.2, and this is a mixed number. It's a whole number and a fraction. And so what are some of the things they might ask you to do? Well, they might say, turn this into an improper fraction. Well, okay, we'll just accept their word. So does anybody know how to do it?
Times 3, 12,
3 times
4.
3 times 4, I kind of learned it like this. It's 3 times 4, 4 times 3, and then you add
1.
1. So 3 times 4 is 12, and 1 is 13 over the divisor 4. So sometimes this is preferred, and sometimes this is preferred, and we have to be able to go back and forth. So let's go back to this. I'm going to start with the improper fraction and say, now let's go to the mixed number. So you remember that this is 18 divided by 5. So if you can do it in your head, do it in your head. It's 5 divided into 18. How many times? And if you need to,
3.
3.
3.
3. So 3 times 5 is 15. How many's left over?
3.
3. So it's 3. The remainder goes here, and the divisor goes here. So you want to be able to go back and forth. And we will learn pretty quickly, I think in the very next section, why it's necessary to go back and forth at times. And so, let's see. That's pretty much what they're having us do. Anybody have questions? This is out of the book. They love these little pictures. Let's just try to look at this one. And it's got a triangle inside of a triangle, okay? So if you count them, there's what, 1, 2, 3, 4 triangles in it. In this one, that's shaded and all of this is shaded. So they're trying to get you to visualize what this number is trying to picture. So this is a full one. And how much is this compared to the total shape? Do I need to redraw it?
1/3.
It's 1/4 because
Oh.
there were originally a total of 4. And let me see if I can't draw it.
Yeah, I can see it now.
Yeah. 1, 2, 3, 4. So when they, on the second picture, when they only had 1, that was 1, and the total is always on the bottom.
Mhm.
For a lot of things we'll do, we'll put the total on the bottom. Okay. Well, that's kind of okay. Let's do a word problem. So, word problem. Music's, no, I don't want that. Stocks. Suppose a stock is selling for $5 1/4. And then I'm going to write per share. That just means 1. If the price increases by $0.75, what's the new price?
$6.
Excellent. So there's a couple of things with word problems, and you know very well what the problems are. The problems have to do with this. This is English, right? It was English. Let me see if I can get out of that. Let me try one more time. English. I have no interest in English. We want to get into math, okay? I actually had trouble with English in school, so I like the math. But the key thing here is when you increase, that's a word for addition. So it's 5 1/4 plus the 3/4. So although they haven't had a section on adding, I think this is pretty good. 1/4 and 3/4 make 4/4, and it turns out to be $6. Is that looking okay to you? If you think of it in terms of money, 1/4 and 3/4 makes a full $1. And so
That's
5,
what I thought. When I saw 3/4, I thought 75 cents. And then
yeah,
when I 1/4, I saw 25 cents.
yeah.
So I put those two together, and then it was 5 + 1 at that point. That's how I got 6.
Yeah, if we can relate it to money, and especially anybody who's ever worked where you had to handle money, it kind of clicks, don't you think? It kind of clicks. All right. if a man is 71 inches tall, then his height in feet is 5 feet, 5 and 11/12 feet. Okay, this is the word problem. So the person is 71 inches tall, right? And then they said, they already told you this, this represents 5 and 11/12 feet. So that's 1 inch short of 6 feet. So then the question was, can you make it an improper fraction? That's what they want. So we're going to have to go with their word improper. So remember what to do. What times what plus what?
12 times 5 plus 11.
Okay. So again, it's like 12 times 5 is 60. Plus 11 is what?
71.
71 over,
You put 17.
oh Lord. I'm getting dyslexia, dyslexia. Okay,
Too long.
thank you. I was distracted. My cat stays with me and then all of a sudden wants to leave. And so I about the cat.
Good, right?
18 years old. Hi, Dan. Did you have a question? I saw a hand. Dan?
Oh, no. That
You're
was
talking to me right now. I haven't learned it. I'm doing this blindly because most of the people I can't see. Okay. What do you think? Has anybody, are there problems that we can look at?
Could we reduce that for the right answer as well? Is that the answer?
No, because what would happen, it would go back to this.
Oh, okay.
And 11 over 12 doesn't reduce, does it?
No.
And so people use the word reduce. Yeah, 71 is a special number. Has anybody ever heard of prime numbers?
Yes.
Prime numbers are numbers that don't divide any further except by themselves or one. And so 71 is a prime number. So how do you get 71? 71 times 1, which won't do you much good. As things go, but prime numbers are next. Okay. I think that's pretty much it. What do you want to do? Did anybody have trouble? Okay, let's go to the website. Somebody's asking who can see the messages. It's possible to send a message only to me. Has anybody figured that out?
Yes. I figured out
Yeah,
now.
yeah. And so, or you can send it to everybody. So when you go into chat, you can do it. And so there we are. I want to go over to our website. And anybody having, here we go. So let's talk again about the calendar, because I know a few people have entered the class late or later than everybody else. And so what's happened is we started, what was it, September 26th. We had a couple of classes. And so the sections 1.1 through 1.6 are already from last week and are past due. If for some reason you need to still do them, then just let me know. And we'll figure it out. And the easiest way to do it is to come over here to message. The message that you send only goes to me. And so if you need something that's only about you, send me a message from XYZ Homework and we can definitely deal with it. Okay? So the other thing is using late passes. For instance, let's say this 1.7 is due tonight. Okay? And so if you finish it before 11:59, it's good, it's on time. But you can use a late pass. Has anybody tried to use a late pass like on a Thursday? After it's late?
Can I still use a late pass for 1.6?
I think not, because it
Me
needs to be within 2 days.
Okay.
So when it didn't happen, you need to send me back to the messages and ask me to do that, and I'll extend it for you. I'm not going to do this forever, but at the very beginning I will. Okay? Anybody have trouble?
So I
with
had a question about,
Go ahead.
oh, sorry. Go ahead.
Yeah, go ahead.
Oh, I had a question about testing. So every time we like are in class, I make sure to like take notes and stuff. So are we allowed to like have our camera on and use our notes for the test?
I'll have to get back to you on that.
Okay.
You know, I'll have to decide. The test is, it sounds like a test, but it's more like 10 questions, maybe 12.
Mm-hmm.
So each one might be different. Okay.
Okay.
Is there
Yes.
any section we can go over now that we're here? We could look at homework.
Do you see my my work?
I'll have to talk to you individually while we're still recording.
Okay.
I'll look at that. So is there anything else that we can do? Okay. Well, I think what I'm going to do, I've covered all the material 2.1 and 2.2. I think it's been covered. And so next class, we're going to talk about prime numbers. But I think today we'll just stop early. Anybody have a question while I'm still on this website?
Ooh, I got one question. All right. I think it'd be a good idea for me to look at placement numbers again one more time, like the place values.
Oh,
Those are it's a little like the amount of zeros that I need after like a million, that I get confused. You know what I mean? And I might be 1 0 off, like 2 zeros off, and that part is confusing to me. So my question was, say it's 1 million, and there's
okay. So I'm back to here. So 1 million, what?
there's 6 zeros behind it. I remember that part. So say it was like I don't know how to ask this question. So say it's like,
I'm going to just write a bunch of numbers.
yeah. So how many zeros would go after that if I like after I did the place values?
So there's a couple of questions that somebody could ask with a big long number like this. They could ask, take the number 8 and what is its place value? And so, you know, these are the thousands and these are the millions, and this would be billion. So that would be 3 billion. But we're talking about this number right here, the 8. So this would be, those are the millions, this group of three. So this would be million, this would be 10 million. So that would be the answer for what is the, where is the 8?
So like the 942,420, if the 8 is 10 million, 942,420, will they all become zeros?
Okay, so another question had to do with rounding. So take a big number like this and round to the nearest million. Okay,
Mhm.
so what you have to do is locate the million spot, which is here. So that would be a 6, right?
Mhm.
Then the number of zeros you have to put in has to do with how many numbers are left. And there's
Oh,
6.
okay.
1, 2, 3, 4, 5, 6. Now, what do you do with the rest of these? Well, you just copy them in.
That was my question right there.
So you see, you have to locate the correct spot, which in our case was this, the nearest million. And then you just literally 1, 2, 3, 4, 5, 6. You have to change these 6 numbers to zeros.
Okay.
And then the commas would be super nice. Then you
That,
can
that's what happened in the homework thing. There's no commas. All you see is a bunch of zeros on your screen, and if they can get rid of those, it's really confusing.
yeah, I think your biggest problem here was the fact that you got 6 zeros in the problem. Once you get 6 zeros, the rest was just pure copy.
Okay.
And I just made a mistake. Can you tell me what mistake I made?
I was just gonna ask, I mean, round to the nearest million, wouldn't
I
it
was
be?
I was so
nothing?
focused on the 6 zeros. What has to happen? What we were rounding.
It's gotta be the 4 and the 8 goes up.
So let me get out of that. I think I need more coffee.
Me too.
Thank you. So when we rounded, the 6 zeros are right, but I ignored the important part. This 9 makes this 6 go to what?
7.
Oh dear. So that's correct. But most people mess this up. And so I was looking over here, but it's actually the very next number, forget the rest, the very next number is a 9. And anything 5 or higher forces this last number up 1.
Instead of going up, you had gone down.
Yeah.
Okay.
If it was a 4, it would go down. If that 9 was a 4, it would go down.
So you wanted, if the 9 was a 4, so let me just rewrite it so that it's 8, 6, 4, 2, 8, 5, 1, 6. And we're going to round to the nearest million. So we're going to round to the nearest million. So that's the million. And so I kind of block it off as a reminder that everything from here out goes to 0. Okay?
Mhm.
But here's the crucial part. The very next number is not 5 or more. So what does that do?
It goes down. Does it go down? Or does
So
it,
I think instead of saying going down, say stays the same.
okay.
Because I don't want you to think, oh, I better make it a 5.
Okay.
It stays the same, or in the previous problem, it goes up 1 like it was supposed to. Like this one here, the 6 became.
So if it's a 5, it's gonna go up. So if that's 5, 4, 2, it's
So that one, if this would have been a 5, that would have, the 6 would have been 7.
okay, I got you.
Got it. Okay, so we're making a little progress. Okay, here's what I'm gonna do. I'm gonna quit while I'm ahead.